Yay, we finally did it. Okay. Let me just check my sound system. Well, never mind. I won't do that. Okay. Okay. So we're starting. As always, I like to start by going to the class webpage, which is cct.lsu.edu/esperant CSC1351. Or if you missed that last step, there's a 1351 link here. At the bottom of this page, we have our syllabus. And today is March 26th. And that says that we're still talking about data structures. And we've got a test coming up on April 11th. Okay, that's exam 3. The 28th is my 20-year anniversary with LSU. Sorry. It's been good 20 years. All right. So I thought that we'd start today. I wanted to talk just briefly about the Tombs of Mars lab. And let me just pull that up. I mean, nobody asked me about it. Nobody asked me about the last quiz. You know, I'm just sitting here waiting to see if anybody asks me. But anyway, I just wanted to make you think a little bit, because I watched a bunch of you do your labs, and I watched the way you coded the nearest method. And there's a bunch of different ways you can do it, of course. And what I did, I just did one thing that I think might be of use to you. So nearest. So what I did is I made another method called add, right? And it took my array list, it took a row and a column, and I just enumerated all 4 possibilities. And the way my add method worked is I just, if the thing was the wall, was not a wall, then I added it. And rather than try to figure out whether row and col was in bounds, I just catch an array out of bounds exception. And if I catch it, then I ignore it. So so the point to look at here is I encapsulated the logic into an add method so that I didn't have to repeat this logic 4 times. It saves me a small amount of coding. You could also try to put it into a loop. You're looping over 4 things. I'm not sure that it's worth doing, but there's a number of different ways you could potentially write a loop for this. And you could say, I think this will work. Let me just try it. So I'll say for I don't have a convenient, well, okay, I'll do it this way. For int r equal -1, r less than equal 1, r plus plus, for int c, right? It's figuring out what I want it to do. I'm going to say if r equals 0, exclusive or c equals 0, add result, and I'll put a plus c and a plus r. I think that will work. Unfortunately, of course, this is in the way again. And where can I resize this thing? All right, I'm going to stop share for a moment because there's no way to get it at the screen. Zoom has blocked me effectively. All right. So now I have way more than enough room. Okay, so let's see if this works. So I'll say tombs. All tests passed. Okay, so the logic I used in this loop, right, is I'm going from -1 to +1 on all on the row and the column. And I want an exclusive OR. One of them is 0, the other is 0, but not both. You're all familiar with exclusive OR, right? Who's not familiar with exclusive OR? Okay, there's a couple of people. So an OR means either, so and means both things have to be true. A and B both have to be true. And or means at least one of them is true. Okay, they can both be true or one of them can be true. An exclusive or means one of them is true, but not neither of them and not both. All right, so I can use an exclusive or here to find out which row and column I want. And I'm only iterating over 4 things, so I'm not sure that it's worth figuring that out or writing code that way. But I think it's worth factoring out your logic into an add method. That's all I wanted to say. Any questions? All right, so what I want you to do in your life, I want you to be thinking about, when you're looking at your code, can I simplify this? Can I take something I've repeated, put it into a method or a class, and just reuse that same thing, right? Reusing code is victory when you're programming. Reusing code means simpler code. It means easier to maintain code. Usually it means easier to understand code for the next person. Okay. Let's go back. So we were talking about is there a question? No? Okay. We were talking about hash maps. And let's see. My hash map. Slideshow. Maybe that helps. All right, and we were talking about my hash map, and I just want to sort of remind you how that worked. In this case, what I did is I abstracted away a hash method. And what that hash method does, it takes an object that's a key, and it finds that hash code from the key. But the hash code isn't directly usable. It can be negative, it can be 1,000,000, it can be, something that doesn't map well to an index of my list of buckets, but I need it to map to my array of buckets. So what I'm going to do, first, I'm going to wrap it in an absolute value call so that I get rid of the negative sign. And then I'm going to do a % on the buckets.size. So now I've taken this essentially random number and I've mapped it onto my, my list of buckets, okay? And that's the only real logic you need to make this work, right? The rest of it just sort of follows. So now I do a buckets.get and I have my hash key and I do that for my get and my put, and that makes it easy. Now, for my entry iterator, I guess we didn't discuss that. Let's see, what I did is I put all the tricky logic into the entry set. Okay, and then I reused the entry set.
I was thinking of telling work I could pick up.
Could you mute your microphone, please? Thank you. Then I reused the entry set to get the key and the value iterators, right? So then I didn't have to replicate this logic because it's not as simple as it could be. So the way the entry set works is, as always, I start by creating a new, well, first I have to create an iterable, right? An iterable, that's the empty set that I can iterate over. And then inside the iterable, I have to create an iterator. So I have an anonymous inner class inside an anonymous inner class. Whoa. All right. And then inside this method, inside this class, I have a field bucket, which I set to 0. I have iterator bucket iter, and that is initialized to the first bucket. So I'm saying buckets.getZero.iterator. And then I have this method called advance, and it has a loop that says while true, and if my bucket number, this bucket, is greater than or equal to buckets.size, I break, and there's nothing I can do. Okay, if the bucket iter has a next, then I break. If the bucket iter doesn't have a next, then what I'm going to do is I'm going to increment the bucket by 1. And if bucket is less than buckets.size, I'm going to update the bucket iterator with the new bucket. Okay, so this is the logic that I have here. Is I want to go through each bucket in my bucket list, but I have to keep track of both things, right? I have to keep track of which bucket I'm in and where I am in each bucket inside the iterator in order to make that happen. Do you follow all that? Does anybody have a question? And no, it's not okay to be lost. Yes.
So can you go through like what the iterator do again?
So an iterator, right, is a way to go through. It's something that can be used to iterate through a list or a set or a map or just any kind of collection of things, right? It's a way that we can loop through everything in an abstract way. So if you want to loop through an array, right, then you have to say, what do? You write for int I equals 0, I less than array.length, I plus plus, and then you say array square bracket I, right? And that's unique to an array. And you can do something similar for a list, but instead of .length, instead of a field .length, you have a .size method. And then you have a .get to get the field, to get the value out of that list, right? And those things are totally different. And then you've got a string, right? Anyway, so what you can do with an iterator, right? An iterator works the same way, whether you have an array, a list, a map, or a set, right? It just says it has a has next and it has a next method on it, and it just walks you through the set. Make sense?
Yes.
Okay, so what we want to do is we want to make an iterator on our hash map that goes through the entries for the hash map. And the entries are key value pairs, right? Entries are key value pairs. So what I'm going to do, and because my hash map is organized into buckets, I'm going to start my iterator in bucket 0. And I know there's always more. I don't have to check to see how many buckets there are. Buckets always going to be more than 0 because it's a fixed number. The way I've written my hash map, it's a fixed number that it's always the same for the life of the hash map. And it's a fixed number that's greater than 0. So what I'm going to do is I'm going to initialize what bucket I'm in and store that in integer. And I'm going to get a bucket iterator for that bucket. Now, this advance method, what it's got to do, what advance needs to do is it needs to say, do I have any more items in any of my buckets, right? So if and it has to ask the first question, is my first bucket empty? And if my if my current bucket empty, and if my current bucket is empty, then I have to increment to the next bucket, right? And then I have to get the bucket iterator for that one. And I have to ask, is that bucket empty? Now, it could be, right, that when I go to do this, I have 100 buckets and only half of them have anything in them. So sometimes when I advance to the next bucket iterator, I'm immediately going to say, hey, it's already empty. I got to go on to the next one. So that's why it's in a while loop, right? I have to keep going through until if I run out of things in one bucket, then I have to keep going on until I find a bucket that has anything, or I reach the end of the list of buckets, in which case I know there's nothing. All right. And if I'm at the end of the list of buckets, then I don't update the bucket iterator. The bucket iter object is exhausted, and in fact, the whole thing is exhausted. So that's the logic. And once I have that advance method in place, now I can say advance in front of my has next. And then I can just return bucket less than buckets.size. If bucket is less than buckets.size, that means that advance found something, okay? And if advance, and notice that advance, the way it works is If the current bucket iterator has something, it does nothing. All right. And then I say next, and my next method takes the bucket iter and it calls the next method and stores it in an entry and just returns it. And then the remove method just calls the remove method because I'm using my bucket is an array list and it implements the remove method. I can also implement the remove method by just passing that along and through the iterator. Okay, does that make sense? Is there a question? Yes. Bo, yes.
Does next return entry or does it return the key?
Next returns entry, right? Because what I'm doing is it's going over a bucket, and the bucket is a list of entries, right? So the bucket iter must be an entry. Next question. Drew. Well, that means, so the point is the advance is what it's trying to do is it's trying to advance the bucket iterator until there's an entry that it can use, right? So if bucket iterator has next is true, there's nothing for it to do. Any other questions? Yes, Olivia. I'll explain the advanced method one more time. So the idea of advance, right, is because, and this is a tricky class. This is a tricky thing to write because you're kind of doing an array of a list of lists and turning it into an iterator is sort of what's going on here. If you just wanted to if you had the list of buckets and you wanted to iterate through all the items in the list of buckets, you could just write, you know, two nested for loops and print them. That would be easy. But fitting it into the iterator extraction is a little more abstraction is a little more tricky, right? And that's what we're trying to do here. So the logic is we want advance to move ahead until there is something for me to get, until there's a has next, right? Until has next returns true. I want to advance until has next returns true. Now, it may hopefully be, and even hopefully it will be true at its very first invocation, right? Because I've initialized bucket iter with the first bucket, with an iterator over the first bucket. If there are no more buckets, right, then I'm going to break, and because there's nothing I can do then. But and if my bucket iterator has something in it, then I'm already set. I've accomplished what I needed to accomplish, and I can break. However, if my bucket iterator has nothing left, and my bucket is less than my buckets.size, then what I'm going to do is I'm going to increment buckets by 1. And if bucket is still less than buckets.size, then I'm going to reassign the iterator with the next bucket iterator, okay? And if I do that, then my while loop will continue. And if my while loop says, hey, your bucket is now past the buckets.size, then I'm going to break because there's nothing more to do. And then I'm going to check my bucket iter. And if it says, if has next happens to be true, then I found what I was looking for and I can stop, okay? But the point is I have to have that while loop in there because I might have to advance to the next bucket several times, right? Before I get what I want. Does it make sense? Anybody still have a question?
Just want to make sure I understand. It's basically
Fook, right?
Yes, sir.
Yes.
It's going to keep advancing until it's find something and
Advance until has next returns true. Right? And when has next returns true, it doesn't use up that value. It just I mean, I could name this advance until has next is true. It's a little longer, but maybe it would be a nicer name. All right, but once I have this advance method, this is the key trickiness, right? Once I have this method, then it's easy to write the rest of this. I say Boolean has next, I call advance to make sure I have something if possible. And then I can just return bucket is less than buckets.size. Because if there's nothing more in any of the buckets, that test will fail, right? Right? Okay. All right. Then my next method is easier still. I just go to the bucket iterator and get the next method because I've already determined that there is something in it. And then my remove method, well, I don't need to figure that out. Somebody else figured that out. I just have to remove the item from the bucket that it's in. And the list iterator that I'm using, right, already knows how to do that. Any questions? Okay, now that was hard enough, right, that I don't want to do it twice or 3 times. So what I did when I wrote the values iterator, right, is I said new iterable. I created my, first I created a final iterator entry iter, and I just got the entry set iterator. And then I return a new iterable. And then inside the new iterable, so I still have this still have this doubly nested anonymous inner class. But here, my has next is just going to be entry iter dot has next. And the thing I'm going to return, I'm going to get the entry, and then I'm going to call the get value method. So I'm just going to call the value off the entry and use the entry iterator, because the entry is a key value pair list, right? So it's easier for me to just go through the values this way, rather than trying to redo that logic, right? There's no need for me to redo that logic. And the key set, the only thing different between the values and the keys is I call get key instead of get value. Okay, make sense? So in your life, when you write iterators, you have to sort of think this way. You have to, you're going to want to do something similar to what's in this advanced method, but you have to keep track of where you are in both things. All right. Any questions? All right. I have a toString method. So what I did in my toString, let's see what I did in my toString method. So I created a builder, then I went through my array of buckets, and if my buckets.size is equal to 0, I appended a minus. Otherwise, I appended a star. So the way the toString method, right, is just going to show me which of my buckets are populated. That's the way I chose to write it. I'm not sure what the built-in method does, but that's what my thing chose to do. And then I have a test method where I'm going to go through here and I'm going to make sure I understand how all this works. And was it this one? Oh, come on. Right. So this was and we looked at this last time, but I just wanted to run it again. So we're going through the array. I had 20 items in it, and I have this numval class, which you may remember. And the numval was the key. And I used it to look up the value, which was just an integer. And it was I time, it was the key squared. Right. And then I did it again using an iterate. I did it 2 times, one using one kind of iterator, another. Let's look at what I did. Okay, so first I go through and populate my hash map. Then I go through and I print it, and I print out. I go 0 to 20, and I create a numval key each time, and I use that to look up the value, and I compare that to recomputing the value. And then I used an enhanced iterator on my keys iterable. And then I just say I and h.get. And then finally then the next thing I did is I put a string in there, and I did a list through the entries, and I showed the entries. Now the entry has its own toString method on it. Huh, I thought it was. Okay, I put it in a separate class. The entry has its own toString method on it. And I have to make sure I have that linked in the notes. So the entry has a final object K. Why is K final? Who can tell me why is K final? It has to be final.
Again, like,
Somebody's talking. Okay. Why does it have to be final? Who can tell me? Yes. What's your name? Luis. What? You don't want your key to change. What will happen if your key changes? Your map won't work, right? Your map will try to look things up and things won't be in the place where they belong. It's kind of like, you know, if you went into the library and you came up to this book and you scratched off the author's name and wrote a new one and left it on the shelf where it was, right? How's anybody going to find that? All right. So the key has to be final, and the key should be something that you can't change. And then the value, of course, can change. That's sort of the point of the whole thing. And then you have a toString method, which just shows you the key and the value. All right. Any questions about how that works? All right. Obviously, you've all mastered it. Let's have a quiz.